Now we're getting to the meat of the work. So what we're looking at right here is writing in standard form. We've got this equation, y equals negative 1/4 x squared plus 3x plus 6. Ooh, write it in standard form. Now, this, you guys, is standard form in the form of ax squared plus bx plus c. What we're working with is what we need to get it into is, well, since the y is on the left-hand side, that's going to be negative 4y minus k equals x minus h squared. And actually, it's a positive 4. I'm just getting into the lost part of my answer. So that's what we're looking at. That tells you, it's negative 4. It's positive 4p. That's what it is. So that's what our goal is to get to, but we obviously need to figure out the pieces in it. What we're going to do is we're going to do this by completing the square. So we're bringing back an old term. And it's, some people dislike it, but I think completing the square is nice because it makes our life easier. So let's go ahead and start off. I'm going to close that off just so we can start fresh. We've got y equals negative 1/4 x squared plus 3x plus 6. So when completing the square, you're going to go ahead and portion off your a and b piece and pull out a greatest common factor. So in this case, what I'm going to do, I'm going to pull out a negative 1/4. That's going to turn this to x squared. And then that's going to turn that to a negative 12x. And we still have this plus 6. So I factored negative 1/4 from the terms that have x in it. We can call them x terms, and that doesn't look like an m. There we go. All right, that's the first step. This is going to get a little smaller. Now, the next step is we need to go ahead and complete the square, so we need to figure out what's going to make that piece whole. So the way we do that, it's negative 12 divided by 2 squared. So that's minus 12, and then negative 12 divided by 2 is 6, negative 6. Negative 6 squared is 36. We are adding 36 to the inside, which means we need to add 36 times a negative 1/4 to the outside, which we're adding because this is a negative. So 36 times a negative 1/4, that's a negative 9. So that means we need to add a 9. So we just completed the square in that piece. Now we need to factor. So how we factor this out is it's just going to be x minus your b term divided by 2. X minus 6 squared plus 15. Now we need to get it into this format. So we're going to move over this 15. Y minus 15 equals negative 1/4 x minus 6 squared. My pen is not working very well. Then we need this to go on the other side because that's where the focus sits. There needs to be nothing with this x minus 6. So we're going to multiply by a negative 4. And we are left with a negative 4 times y minus 15 equals x minus 6 squared. And that, folks, right there is your equation. Now we need to go ahead and graph it. So I'm going to insert my table in, or my graph, not my table. Go ahead and draw some lines. I'm going to eyeball, because we're going to have to scale. We're going to have to look at what we're doing. So this is opening down, because it's a negative 4. So it's going to look like that. Where your vertex is at 6, negative 15. Nope, 615. So, let's see. I'm going to draw, we're going to obviously have to scale our axes. We're going to go like that. 2, 4, 6. None of those are even. Okay. 2, 4, 6, 8, 10, 12, 14, 16. 2, 4, 6. So we're going by 2s on these, you guys. We got to scale them down. So first thing we want to do is we need to go ahead and label our vertex. Our vertex is at 615. I'm just going to go ahead and put a V there. Then we want to find the directrix. The directrix is y equals k minus p. So that gives us y equals k minus p. Well, we need to find p. P in this case is a -1. So that means our directrix is 16. So that just happens to be the piece I labeled across. This is quite messy. For some reason my pen, the battery must be dying. It's acting a little finicky. And then a focus. Our focus is h, comma, k plus p, which is 6, 14. That's also the same equal distance from the vertex to the directrix as the vertex to the focus is. And then our axis of symmetry breaks it up in the middle. I'm going to go ahead, grab a couple points, create a table, x and y, we'll do 0. Let's do 4 instead of 2. Because we're looking kind of at a scaling, and then we'll do 8 and 12, because that's all around that 6. At 0, we're at 6. 4, we're at 14. 8, we're at 14, and then 12, we're at 6. Obviously, it should be mirrored on both sides. So let's go ahead. 0, we're at 6, 2, 4, 2, 4, 6. And 12, we're at 2, 4, 6. So those are equal distance from this focus to the point to the directrix. They're all equal distant. And then we've got our 2 points right here. And that's all we need to create our parabola. This one's a little tighter at the beginning, but that's what it looks like. It should be a little more curved at the top. And there's our graph. This is a long one, but this is a big chunk.